or finalize that table. Really what finalize level is doing is each of these at this point, when this gets done being called, the relative position is unknown yet for each platform. We know their relative, but we don't know their absolute position. So it takes the center row and the center column, and it says, okay, now I know where the player is. Now I need to adjust how far away from the player each of these elements is. So in other words, it's looking at this data. It knows that this is row 1, column 1, and this is row 2, column 2, etc. But it doesn't know where the player is yet. So it just says, okay, that's row 1, column 1. But until I know where the player is, I'm not going to assign an x and a y value. But once I know that the player is at, let's say, row 5, column 5, then I can make this the correct distance away from that. It's a way of calculating positions. Perhaps this will become more clear when I run through the code.
But it's all relative to the position of the player. Okay.
Yeah, this is the key. The key concept here is that everything is relative to the player's position. So it's just an easy way. It was an easy way for me to set this up to make the camera code easy to write.
Okay.
It's not something actually that when people are digging through this they need to think too much about. I would rather that people who look at this be concerned more with the concept of using individual builders to do work and understanding a simplified way of laying out a level. And if they can grok that, then the one additional level of complexity here, no pun intended, of understanding the premise of having a center position for the world, that's icing. But if they don't quite get that, it's still, if they can pull the rest of the lesson out, it's good. So let's look at the convert to level record, and then I'll show you what these things look like. In fact, let's go back up here to line 50, where I defined this function. The function's job is to basically take whatever subtable I pass in and convert it into something useful. So let's see what it looks like when I first look at the input content. So input is a table, and this function here, table print r, comes from SSK. It's added by SSK to the table library, and what it does is it prints out a nicely formatted listing that shows you a table and how it's laid out and everything that's in it. So when I run this, let me bring up and I finally learned how to make these things legible so that people can hopefully read this console output here. When I run this, print R basically prints out these tables, entry by entry. So entry 1, underbar, 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 etc., 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 and C1. So this one is obviously printing out this table right here. And as you can see, this comes out as a big, long, flat list that goes from 1 to 64 entries. So we still have to sort of like turn that into rows and columns. So let's start with that. I'm not going to go too deep into this. People can pretty much figure this out. But what I do is I have some variables here where I say I'm starting at row 1, column 1. Then I have a marker where I assume that the center of the world is at row 1, column 1 for now, because I don't know what it is. And if for some reason I'm like goofing around and I don't put a player definition in, I still want this to work. So in this case, I took the player out. But because it assumes that 1 is the center of the world, this is actually probably not going to look good. Yeah, that doesn't look good. So 1 is the center of the world, but there's no objects there. So let's go put an object at 1, just to make this a little more clear. So let's put a square marker there. This is the center of our world, and let's put another one down here, just so you can kind of see this going. Now we should have a line of square markers that go down diagonally, and we'll be able to see 2 or 3 of them.
So before the pieces were there, they were just off the screen. We couldn't see them.
Yeah, the pieces were there, but because this camera was centered on this one, you couldn't see them. So now we got one here, we got one that's diagonally down, and we got no player, so I can't move around. but you can assume that there's more going down and way down off the right, off the screen. So again, the reason that's occurring is because in the level loader, I put in some code and I assumed that for now the center of the world is at 1, 1 because I don't want this to break if I'm messing around and I don't put the player in. So let's put the player back. Everything goes back to normal.
I think it's interesting you chose B for player.
Well, B for begin. I could have put P
Oh.
for player too. You're right. I wasn't really thinking about the nomenclature at that time.
Gotcha.
I was just trying to get non-overlapping. Originally it was S for start, but then I needed S for square, so I'm like, okay, I need another thing that means start.
Okay.
Begin.
Sorry.
B.
It's your
Good,
system,
done.
man. It's your system. It's okay. It's,
Yeah,
you know.
you could call it anything though. That's the beauty of this. It's easy to change. Okay, so far, row 1, column 1. We're assuming that the center of the world is center row 1, center column 1. Now we basically loop over input, which you'll remember is a flat list with 64 entries, and each entry is a table that contains a 3-letter character in it. So it's basically, actually, I take it back. Each entry is a string, not a table, which is just 3 letters. So we need to turn 3 letters into a useful record or some kind of information that will later let us build that object. So what do? The first thing we do is I take and I put the one we're looking at, and I put it in a variable called entry. And then I use a function called split. Now split does not exist in the standard library, but if you don't want to use SSK and you want a split function, you can find one online. I extracted my split function from an online Lua some site that they had a bunch of Lua samples and solutions. But split is nothing more than a function which has been added to the string library. And what it does is it looks at a string entry, and then it says, let me find this symbol, and I'm going to treat that like a marker that I will separate the string. So, for example, if we were looking at this one, it would say, I found the marker, and what I'm going to do is I'm going to return this part. I'm going to return table, and this is going to be entry 1, and this is going to be entry 2. And if for some reason I did this, then the table would have 1, 2, 3, 4, 5 entries. Entry 1 would be S, entry 2 would be 1, 3, 4, and 6, etc. Basically, it's just a nice function to take a string that has some unknown token until you pass it into split, but you use some token, and then you can separate the elements of that string into sub-elements in a table. So then we can iterate over the table and get the first part and the second part. So this level loader thing basically is designed to have 2 parts. The first part identifies the builder, and the second part identifies any special positioning rules, like for example the coins or the spikes, where 1 is on the top, 2 is on the right. What I needed was some way to put that into a very easy to encode string and yet later separate it out. So that's what I've done. I have a string, I use this as a token, and then I return entry that then has basically a table. I've converted entry from a string into a table. So the return value of this gets assigned to entry, the string that was in there gets wiped out, and now it contains a table. And if we looked at that, it would look like this. So now you